So I recently joined Microsoft 6 months in. I'm a manager in digital and app innovation, and I'm a data scientist, an AI person, and data person masquerading in software because everything really is a software product at the end of the day that we build. Used to be a data platform and AI MVP because I used to absolutely love doing things like this. Unfortunately, I don't get any curry today, even though I'm in Birmingham. But pizza will be a good substitute. I'm going to hand over to Isaac for Isaac to intro himself.
Sure, 100%. So hi everyone, my name is Isaac Marsu. I am a cloud solution architect from Microsoft. And I'm kind of a Microsoft born baby, so I started my whole career out at Microsoft. I've been here about 4 years now. I studied, I specialized in the DevOps field. So while this is mostly my bread and butter, you've got Steph as well, who's also, this is the bread and butter along with data science. So we're talking through, as you said, the whole concept around it works on my machine. So that's pretty much me.
Great. So I'm going to cover why the phrase "it works on my machine" is bad, what the kind of company symptoms are for what causes that. Then we're going to talk about how we can get you away from your machine to solve some of the problems. Then we're going to tackle some of the challenges of certainty before things go live. So instead of having to test lots of things on your machine and just hope it works in production, how can we have that certainty without 6-month UAT cycles that everybody hates, and by the end of it, software has gone stale? Then how we can make sure it works in production, so that when a user says there's a bug, how can we see if there is actually a bug in production without trying to reproduce it locally? So, working on your machine. Hands up who has had a working laptop with everything installed on the first day of the new job before? Has anybody managed it on a single day? No, right? Local machines are hard to set up. It really sucks. And it's a huge waste of time. If it takes you a week to get your machine up and running, configuration-wise, that's a week of being paid, of the company paying you, where nothing useful is being done. And it's not like you sit there enjoying doing next installs of Visual Studio, waiting for like 5-10 gig of downloads to happen. It's not like it's your favorite MMO. So if we can, we have this problem with just getting the machines up and running. There's also the fact that we get given like an 8 gig laptop because they're trying to cut costs. And it's like, I can barely run Chrome and Teams for that, right? So then we want 16 gig, we want 32 gig. We're really happy if we get that like 5 kilo laptop with the 64 gig in our servers. And that's often what we need just to be able to test a bunch of things running locally, have a few containers going, a couple Kubernetes pods for testing. So we end up having to have lots of really big devices that get old really quickly because we use them hard. And then it's a security nightmare for the company. We've all seen the data breaches where somebody leaves a laptop or a USB stick in the pub. Hopefully none of you have done that. But when everything's on the device, that's really difficult. And when you're testing things and checking against production systems and different bits and pieces on a single device that you have local admin permissions on so you can install stuff, it's a really big lateral movement security risk. Because if somebody can break into your laptop, they can break into all the different systems. And it's also a nightmare because if you put a version of .NET, a version of Python, and doing a bit of Ruby as well, and something goes wrong on an install and it crunches, that device is, you've got to spend time rebuilding that device, taking a couple days out of your time. So then you're not productive, and it's a nightmare. So a lot of the problems that we have with it works on my machine is actually this whole problem with provisioning things and testing and managing things on local devices. So local devices, great for checking out Facebook, but if we can get our development away from these devices, we can hopefully have a much safer easier, and more productive time. Here's some stats. So if you're wanting some of these single day setups of your getting up and running, digital natives, the latest, greatest startups that we all know and love, 30 minutes to get a dev environment going. And none of us could put our hands up to say we got our dev environments up in one day. So we've got a lot, we can have a long way to go. And it's a really big problem. You know, we're taking 3 days to get up and running with dev, 2 weeks to test some code, 5 days to get that merged in and all the pull requests and merge conflicts and things solved, and then 5 days even on beyond that to get it into production. You know, that you're looking at kind of a month minimum for a change in most places. And these days, more than about half the teams that are in enterprises are looking to release code every day. Now, yes, there might be 50 people in those teams, so each person might only make a change once every, say, 50 days, and you've got the rest of the time to fix things. That probably doesn't happen. As a software engineer, even a data scientist or data professional, we're making changes personally a lot more frequently. And if we're ending up telling our testers, our bosses who are responsible for quality, and our users who need to use our stuff, that you tested it on my machine, then it really isn't scalable, because you have to test all of these things when you're trying to get faster and faster with change. So we really need, if we want to be in that every day, multiple times per day, you cannot rely on working on your dev machine for certainty. So next up is, how do we get away from that local dev, right? How do we not have to sit there doing next installs of Visual Studio just to be able to do some coding? And there's 3 steps, 3 incrementally more complicated solutions you can use today. So vscode.dev or github.dev is a way that you can look at your repo online, in browser, in VS Code, be able to make changes and commit it. So it's great for light editing. Probably not great if you want to be able to run tests and things that are kind of interactive that you want to do versus continuous integration and continuous deployments. If you want to be able to do some local testing effectively, like run npm, run .NET build, initiate unit tests, then GitHub Codespaces is a really great tool. GitHub will automatically spin up a container with all the dependencies you need based on your repo's contents to enable you to have all the things like .NET runtimes, npm runtimes, to be able to actually locally code, and be able to test those changes before you commit. So this is a great lightweight way of not working on your machine and getting things up and running without needing to install anything. The more heavyweight duty, particularly, if you do a lot of Visual Studio, you like having resharpen things on it, you might have some additional utils like a custom Selenium executable and test harness, all these different bits and pieces. You can pre-configure basically virtual machines that you can access on demand. And the idea in the Microsoft Dev boxes is you can start creating machines that match requirements on a project-by-project basis. So if you're working on migrating something from like old Windows 3.5 .NET to the new LTS of .NET, you want a machine that has both of those things installed side by side so that you can do stuff. You can have that as one off-the-shelf virtual machine, but then somebody else who's building a Django app for a new greenfield system, they can have something with just Python installed. And the fewer things on the machine, the less things there are to go wrong and less things to screw up our testing. So Microsoft DevBox is the heavyweight version when you need lots of custom bits and pieces. If you're doing kind of light full stack dev in particular, GitHub Codespaces is brilliant. And it's literally a button away. And all of this, when I said about GitHub automatically building your container for you to be able to develop in, it's basically relying on infrastructure as code under the hood. And if you haven't used infrastructure as code, it basically means being able to script stuff to make virtual machines and things happen. So you don't have to personally install Visual Studio ever again. You can script the virtual machine to install that for you. And it works not just on your local machines, but on your development environments, your UAT environments, and your production. You can have a single script that defines what your environment looks like, and you can use that to make your personal version on something like an Azure Dev Test subscription. You can have your CI/CD systems on commit deploy that environment to make sure it's not changed. And you can use it to rebuild production if something goes wrong. So it really is a super helpful concept that helps us get away from that local requirement to have all the dependencies manually configured, and and where you're trying to build that certainty that things work by doing local testing. Because even now, our environments that our code, our apps, our databases are operating in isn't fully reproducible. So I want to talk about Codespaces a little bit more. And I mentioned that Codespaces is browser-based, where GitHub spins up a container that contains all the dependencies and showcases Visual Studio Code as an IDE in browser. With that, it looks at the type of code that is currently in your repository. So I'll show a demo shortly where I have a Hugo blog, static site generator. I don't even have a dependency file because Hugo's amazing, all hail Go. But it works out that I'm using Hugo and installs the right executables that I need to be able to test, build, locally serve my blog posts and my site to make sure I'm doing it right. And I've seen it work really well with single page applications and different bits and pieces, e-commerce apps and things like that. And you can have all the brilliant extensions from VS Code running in it. You can have it synced to your GitHub settings, so that to your Visual Studio Code settings. So whether you're working on your device or you're working inside a code space, you get exactly the same experience. So here's a demo I made earlier. As you can tell, I'm far away from the laptop, so this is a Blue Peter demo. So here's my website. I have a repository with Hugo in, and I've got different folders, different bits and pieces. Codespaces, when you have GitHub Enterprise, is right there. And I didn't fudge the time on this. So I created my started creating my code space. It's found a repository container image online for Hugo. It's built that and is now connecting to it inside the browser. So all you need is Edge or Chrome or Firefox or whatever. And now I have a fully fledged VS Code environment. It ended up for this doing a little bit of spin up, but then I'm going to be able to move back over to my terminal and even start running my command line activities. So you can still run, ls and chmod and all the different bits and pieces and bash scripts and things that you might want to locally, but it'll run inside your browser and inside a perfectly clean environment. So you're not worrying about having different versions of things installed. So I can now run Hugo Serve. It's Go, so it's under the hood. So it built my website in less than 2 seconds. Definite plug for Hugo. But then it gives the live preview. It's exposed from the container. And once I work out how to click properly, I wanted to give you the authentic demo experience of me. We then have, in another tab, we can go and navigate to the live preview of my site. And that's it, right? I pressed a button on GitHub. I got VS Code. I was able to run things to test my environment locally, see it in browser. And then when I made my changes, I can commit, I can push, and it's in GitHub for everybody else to leverage. It really is that simple. So I'm super chuffed with how I can install much less on my machine. And then DevBox, as I said, is for the more complicated situations, because you might want to have a local DB instance for your SQL server. You might want some extra multiple containers running for testing a pod. You might need different bits and pieces. So DevBox is how we can do that, but they can be centrally managed and you have them on demand. So today I'm working on this project. I go and I turn this virtual machine on and I run from that VM. So again, no complicated local installs. And I provided a quick comparison. So GitHub Codespaces is Linux-based. So if you're testing a Windows-only Windows-only.NET, it's not going to be helpful. But for web stuff, some APIs and things like that, really good. Whereas for DevBox, it's much more you're able to test embedded apps, gaming, IoT, different bits and pieces. So you've got scalable options from quick light edits in browser to interactive editable environments to full heavyweight machines in the cloud that can be 32 gig or 64 gig or whatever obscene amount of RAM you need without you needing to worry about your little laptop overheating in the sun. Okay? So valuable to have these options. I'm going to hand over to Isaac to tell us about how we can start building up certainty before we go live, because it works on my machine. It's something we also say when we're ready to ship it. So how do we get ready to ship something?
Thanks, Steph. Just like to say I do feel a lot more comfortable for clicking my hand. You can see me there standing like a security guard, so it makes everything a little more comfortable for myself. So, how can we create certainty before we go live into production? So how do we get that confidence before we go into production that we know that as we're going into production, our code is ready, as we're moving left, as we're developing on Codespaces from DevBox, how do we get that extra bit of confidence and security just before production? And to go through this, I've got a nice little demo here I've set up for you guys. Right here, I've got an ASP.NET website that I've built an e-commerce website. And the three concepts we're going to be showcasing today that's installed in DevOps methodology is one, continuous integration, and I'll signpost when you'll see these methodologies throughout this demo. One, I'll be showing you continuous integration as this moves along. But continuous integration is a software methodology of just as you have a log repository, you can see some issues where you're developing with multiple people. Maybe you both develop on the feature at the same time and you uploaded it, and now you have a clash. And now as you try to upload it to production, you can see that clash in production. And now you failed. You both have to talk to each other and decide what code to use. Bring it back down to your local machine and then try to work through it again. This is the methodology to kind of help you work through that. So instead of a local repository, you have a shared repository where you can build your code. And you can commit that code and pull that code down. So as people are committing to the main perfect piece of code, you can always get that on your local machine and work to that. So there's a way to integrate your code with whoever you're working with, as long as they've got access to this repository. So as you can see here, I made changes to my repository. So that was the CI at work. Here, we've got my favorite bit, which is the continuous delivery or continuous deployment. And the reason I like this so much is because it automates things. I'm a bit lazy when it comes to doing things manually. I like to automate things and make things efficient where I can. And this is where CD really plays a part. So as you're deploying to your production site, you may see that you have local dependencies on your machine. And as you deploy it and you get to production, you realize the production environment has dependencies that you don't have in your local machine. So you also have that error of having to go back down and download those new dependencies. What CD does for you is it makes sure you're always ready for the production ready. You're always in a production ready state. So it relies on infrastructure as code, which Steph talked to us about. And if that concept is always having that code ready and there to actually deploy your code. So here is my infrastructure as code, believe it or not. I just use the classical interface because I like to visually see what's going on. But there's code working in the background, and if you want, you can use code working in the background. And how I enable my automation or my trigger to connect to my CI, to connect to my repository, was that button there, which is my favorite button in Azure DevOps. So what's happening here is I've combined both of these mythologies to kind of trigger a pipeline or a workflow, per se. You can see here, these are logs running in the background. I've got an agent to run a set of instructions for me, and it's just working through those sets of instructions. So I've committed code into my online repository. I've triggered off my workflow. My workflow has realized that there's been code committed to my online repository. What's going to happen now is it's going to build that code through the workflow. So you can see that it wasn't there before, but best practice is to probably put some testing into that pipeline to make sure that you've got your testing features in there. And as I go through that, it will build an artifact, which I can then put into a release pipeline. And this is another infrastructure as code kind of compartment where I can define exactly what platform I want my pipeline to release my build artifact to. And what that will do, that will update my website. And you can see the changes I've made on the website. So I didn't state this before, which I probably should have, but I put a new change in my code to just right underneath the header of my website, Azure App Service Demo, Azure App Live Demo. Along those sorts, you'll see it as it comes up.
CI/CD works.
Yes. So here, we're finally just going through, and as you can see, we've got one more agent running the job for us. And it really is that quick. And this is why I really enjoy this part of DevOps, because I see a lot of developers go through the manual processes. And as for me personally, I hate that pain point of having to do something again and again. And I know it can be automated, like it just breaks my nerve. So something like this is extremely powerful for actually having all the developers have a shared repository to remove that pain of having to kind of fiddle around of who's doing what on what code. Sorry. On who's doing what on what code. And instead of having that pain point, instead of having those manual processes, instead of having that kind of repeated action again and again, just create a workflow that does that for you. Just create a workflow that always ensures you're in production ready state. And this is what it entails. So hopefully, once this refreshes.
Still thinking about it.
Yeah,
I guess it's got a cold start.
Yeah, don't have Sky as your internet provider when you have problems like this. No offense to anyone Skype here. So as you can see, that's my change made there. So I'll talk to you a little more about some of the services or the solutions you can utilize to achieve CI/CD, and that's how we just call it in DevOps, or just CI/CD. You first have your GitHub Actions. So if you have a flavor for a more open source platform, where if you're familiar with GitHub, it supports open source templates, so you have developers that can talk and collaborate regardless of organization or company. So if you want to download some open source templates to kind of grab your workflow or your pipeline instructions, that's perfectly available in GitHub Actions. We also have Azure DevOps. So Azure DevOps is Microsoft's version of GitHub. I shouldn't quite it's more realistic for me to say GitHub's for Microsoft. It's GitHub's. GitHub Actions is the Microsoft. You know what I'm trying to say. Microsoft DevOps came first. So, Azure DevOps enables that CI/CD, and that's what I built the demo on. They both do the exact same thing. However, Azure DevOps is if you have more private kind of repos that you want to keep safe, that this is the place to be. Also, it has something called approval gates. So, for example, let's say I'm a developer, Steph is my manager. As I'm building stuff, I like to get a little adventurous and maybe break a few things. And Steph has noticed that I like to do that. What Steph could do, or I could do, is kind of add extra security layer. So before we go into production, there's some approval gates that we can put in place when it comes to Azure DevOps. So that's one of the main differences between GitHub Actions and Azure DevOps. It offers that little bit more security. Steph can come in, and as soon as I commit some code and try to fire off that pipeline thinking, yay, I get automation, I'm going to ship to production, Steph can come in and say, no, it has to go through her first.
Wrong way then.
Don't learn.
This is why you automate it, right? So something else presses the buttons for you.
This is why I like automation. Thank you. So when it comes to your GitHub Actions and your Azure DevOps, this offers that end-to-end traceability throughout the entirety of the project. So instead of having different segments being delivered by different people within the business, you now have this workflow that entails 90% of the delivery cycle. So you can do your testing with that workflow, you can do your quality assurance, you can build in that workflow. This gives you that end-to-end traceability to see exactly what's going on. And to automate all those processes, you're going to have to get some of your developers, your operations, your quality assurance, your testers to do, kind of streamlines that into a centralized location. You can see exactly what's going on at what time. I've got to write that down. So, going on and talking about some more hazards that we can kind of circumvent. We've got a feature on GitHub Advanced Security, and we've got the dependency bot. So, I'm going to go back to my example as me being a developer using that website per se, and Steph is my manager. What could possibly happen is I can go into that website, make some changes, commit some new code, but maybe I was a little bit misbehaved and actually left a secret within my code. What would then happen is dependency bot would pick that up and it would reject that code before it can go to production. That way, I can kind of scan for my vulnerabilities before it goes to production. And as you can see, some of your software deliveries, the later you catch your vulnerabilities within your code, the more expensive it is to kind of medicine that situation. So the sooner we catch it, the less expensive it gets. So you want to catch it around that development state. And you can see that most development cycles before this or previously have unchecked dependencies. So like I said before, you may have local dependencies that you thought were ready for production. And maybe it went through and actually went to production. But you found out later on that that dependency was actually vulnerability. So what we do here is we catch that early, right before it gets anywhere near to that £1 million stage. So you really want to stay away from the red. That's when your managers start pulling you in. So I talked about how we kind of secure or make more confident at the right-hand side of the delivery cycle, like how we get right before production. But how do we do it on the left-hand side? So as we commit code, how do we kind of get more confidence that we can make real good and safe code? And we can use this solution right here called CodeSQL. And this basically just lets you test your code's logic before you commit code. So if you saw the pipeline, it really quickly, and it just happened right at the end, there was an agent job that said CodeQL, which basically just scanned the logic of all the code that I committed in my repository. And this way I can test to see if I'm committing the right piece of code. Are there any changes I can make? Are there any major issues with my code? And that's how we can kind of protect both ends of the spectrum. So right before production, or right after we commit a bit of code. Now, we'll talk about test plans. So this is for the testers in the building. However, DevOps tries to move away from the whole testers, developers. All of it is conjoined, as you can see, when it comes to the workflow. And what we have with test plans is a way to actually integrate your testing within your workflow, so you can automate that testing aspect as well. So your unit testing, your platform testing, scenario case testing, you can do all within test flows, and that test plans is able to be embedded into your workflow. Now, as we get to production, there's different strategies we can use to kind of expose certain features to our users. So, for example, let's say we want a new feature of a shopping cart on the website I created. There's ways we can expose that to users to kind of test that it works in production. So moving further around in that delivery cycle, how do we further add assurance and confidence to our code or to our application? We could use some of these deployment strategies. And these rely on something called feature toggles. And feature toggles are just your way of turning off and on different features and exposing them to your customers or to your users. So the one I'll flag in this case would be blue-green deployment. So say, for example, again, I'm going to use this website, this e-commerce website that I showed you to you guys. I have the option of actually building two of that e-commerce website. And what will happen is I've got one built in my dev environment, and I've got another one built in production. What I can do is I can turn the features and test the features on that dev environment. And once I've tested it, with maybe some load testing, maybe add some user traffic to that dev environment, once I'm happy with that, I can switch them over. So that new dev environment with the new added features that I've tested can now become my production. My production becomes my dev environment. You can see here, it's a very easy way to kind of smoothly transition into one of your new features. You can imagine as you're adding new features and you're testing them, your website may be down for maybe 20 minutes, 30 minutes. And for some companies, having your website down for 30 minutes could cost you millions, especially on if you're a retail site and it's Black Friday. Now I want to talk further about some of the approvals that you could add in place into your workflow or to your whole delivery cycle. Like I said before, as I'm a developer, let's say, again, it will do features, want to make sure that there's approval gates. Dev's not only the one that can approve those changes made, you can also add in like automatic approval gates. So you kind of specify exactly what needs to go on. Maybe you have some policies that this code needs to adhere to. So what these approval gates will do is that it will test your code against those compliance and then pass it along or either reject it. Regardless, you will still get those logs and analytics to kind of see where it went wrong. So again, if you need to enforce policies and developers, you can see that they go too far out of scheme or you need to kind of rein them in a little bit. There's also this feature available to you to kind of rein that in. So they can't go crazy with the automation and just start uploading code every minute, hoping that they can really utilize that newer delivery cycle of just deploying new features as they want. You can still rein that in and add that policies or your compliance in just to make sure everything's going together. Now, I'll talk to you a little about deployment slots, and deployment slots were making my blue-green testing. Why do we use them? Like I said before, it gives us a way to kind of test our environment with different scenarios and different cases. So, for example, there are release strategies you could use, such as canary releases. And canary releases, let's say you have a website or a dev environment that you want to kind of have a new feature for. So maybe I have a feature with the shopping cart on my dev environment. What I can then do is I can actually allocate a set group of my users that visit the website, and they would get visibility for the new feature on that dev environment. And as I test it, I can slowly start increasing the amount of users that get access to that dev environment. And when I'm happy, I can do the same thing as blue-green deployment, just switch them right over. And traffic management. This is where you really test, or where you really kind of utilize the breadth of your system, or the breadth of your platform. With Traffic Manager, you have the option of, as your users come into your portal or come into your site, maybe you have a dev environment. What Traffic Manager will do for you is it will separate out that traffic among maybe your virtual machine that's hosting those websites. So if you have one virtual machine that's really struggling with the 40,000 users that you have visiting your website on Black Friday, you can use Traffic Manager to maybe spin up one more virtual machine, host the website there, and have 20,000 on each, and you can expand it across like that. So, what have I talked to you about? So I went through CI/CD and why it's important in the case of utilizing that concept of infrastructure as code. So having that infrastructure of code gives us the flexibility to kind of really take a look at our production-ready environment. So how can we ensure that we're always ready to deploy into production once we commit that code? So we looked at moving from local machines, I think we looked at the benefits and the speed of it. But when you look at the speed, it's also important to look at the safety and that insurance. So this will just help us understand that. With added speed doesn't mean less security. In fact, it could mean even more security. So with that, I'll hand it back to Steph.
Okay, so we got it in production through our snazzy CI/CD. The user reports a problem. In the old days, imagine the hoodied, overworked, overcaffeinated dev in the corner saying, well, I tested this feature, it works on my machine, I did it. But you probably did the happy part. The developer knows exactly what they were trying to achieve. So they pressed all the right buttons in the right order because they knew what they were doing. But users are full of problems. So users are often going to find stuff wrong in production, even if we put all of those possible quality gates in to make sure that we increase our certainty when things go live. Because we cannot possibly be 100% certain that something is going to work when we put it in the hands of people in the world. So what we need to do to help avoid saying it works on my machine and be able to start looking at how the system is actually performing in reality is we need to make our production system observable. We have to see what's going on. We can't just rely on IIS logs and hope that we can find something in a stack trace somewhere and really try and find that issue. Instead, if we're always looking at how our application is performing, when it's throwing 500 errors, when it's throwing 400 errors, when the different systems communicate and your microservices are talking to each other, if we know everything that's happening on the system and we know when an error happened, we can click on that error and go and see what caused it. What were the header requests? What's the body? Obviously, don't track in any PII into your log environment. Please, no personal names and passwords inside your app insights. But with application insights, and I've used this brilliantly. So you deploy something, you're confident it's going to work, but somebody does something a little unusual, or a dependency that you had no control over is a bit flaky. So you're in a distributed team, different people responsible for building something, system maybe goes down or has slow periods. Now, instead of going, well, it all worked on my machine with all your local copies of the APIs running beautifully, you can actually say, so-and-so's API that I use slows down on Fridays. We need to fix it. And with that, you can be more comfortable and be able to build a better solution than trying to recreate that on your own environment. And when you start building observability into your system, you're not just doing it at the application tier. You can do observability on the entire infrastructure. So you can track when your systems scale up or scale down, when you have failover operations, how your database is doing at the same time as how your app performance is doing. When did somebody last do an infrastructure as code deployments? Did that fail? Did they change a setting? turn off a feature toggle that you were expecting. So having all of that feed in gives you, and this isn't just in the cloud, you can be chucking your on-premises activities into Azure Monitor as well. It gives you the ability to view insights about what's happening, be able to present it, analyze it, get alerts so that you don't have to permanently be on call wondering whether something's going wrong. And you can then have the system start self-healing and fixing things when alerts happen. So that observability really is a key way that you can resolve that worry that just because something tested well on your machine, that it's not going to work well in production. And the other bit is making sure that it handles load and activity with grace. Because you're not always going to be able to simulate a lot of load on your machine, right? You're not going to be able to chuck 20 million customer records in your database and then start doing queries against it and find out that you've written some pretty shoddy SQL. It's just too difficult on your machine. So you probably test, some people test against like 10 customer records, and then they say this API works perfectly well on my machine. So we can load test and performance test in our production or even during our CI/CD to help us build more confidence that the features we build work in production, not just on your machine. So Azure load testing is a fairly new service that we can start using to chuck scale at our systems. You can put it inside your workflow as well, so you can load test in a dev environment, but it's a really super handy way of doing that load testing. Netflix, to help their super scalable system and to be fault tolerant, used to have a chaos monkey. They wrote apps that basically attacked their systems. So they could see if a microservice was at risk of being DDoSed, or if it had a SQL injection attack or a cross-site scripting vulnerability. It would put all of these challenges into their system like a little angry gremlin to see what went wrong. And this is a great way of hardening your system and, again, building that certainty that things actually work. And Azure has released the Chaos Studio, which basically is that chaos monkey for your stuff. So you can point it at your systems and test it and really build up that certainty that it's safe and it's got the right quality gates. So that is how we can check it works on in production. And the next steps, because I love giving people homework. Isaac talks to me, he thinks he's got it all sorted out. He's just going to ask me some questions, and he comes away with about 10 things on his to-do list. So if you want to build a culture of never saying works on my machine, of basically building that kind of smoother DevOps process, but that one where your users and your managers can trust that you have quality and that you can relax a bit because you know you have all these safety rails that are going to mean your code works in production more confidently. And if it doesn't work in production exactly how you thought, that gets flagged early and fixed quickly, then the first thing you need to do is move online. Stop using a fully installed local development machine to test things. Use clean environments with the dependencies that your production environment is going to rely on. That's the first step. Check out Codespaces, check out DevBoxes. Heck, just spin up a virtual machine. Like even on an ARM cluster, if you use, like Raspberry Pi and ARM processors to test your IoT. Just get rid of your machine as the bottleneck on this. Then build in those quality guardrails. So add in automate your unit testing, check out your code coverage, check your code for vulnerabilities with CodeQL, check that your open source dependencies don't have any security vulnerabilities. or that a package has been dropped from NPM like ltrim, right? And then make your systems observable. Use monitoring, use things like App Insights to be able to, and there's other projects like Datadog and stuff, but be able to see what's happening in production comfortably. So those are the 3 steps to getting rid of working on my machine. And something that you can start doing tomorrow as well, extra bit of homework because I didn't give you enough, is to actually write out what your process looks like. How does stuff get into production? How do you test it and where? So you can start building your workflow, and then you can start going, well, it's got 50 people and 20 different systems, and we're using a machine, a little HP microserver sitting under a desktop to test things as our UAT environment. And you can draw that out and show the horror so that other people can feel that horror and help be brought in on changing things. So hopefully, with the homework, you can get rid of ever having to say it works on my machine, and you'll be better off for it because your code will be better. So thank you all very much, and give a hand to Isaac. He's done brilliantly today.